was there any need to check about some elements, or you could recall all the elements?
Only few. I think.
Okay, almost how many?
90%.
All right, all right. Almost 90% elements are there in your memory now, right? Okay, okay. We have to just be more confident about writing all the S block and P block elements in some days. All right. Okay, I think you can do it in 3-4 more revisions, right? Okay, if you revise it, I think once a day, in 3-4 days, I think you can write it without any help, right? Okay, okay. Now we will continue with our cation. We were writing about the name of cation and how to denote that cation, that particular cation, right? Okay, okay. Let's start by taking name of the cations of group 1 element and group 2 elements. It is already there in your notebook. Can you just, yes, can you read it out for me? You have to read it out. You have to say like H plus and its name is hydrogen ion.
Hydrogen.
Yes, like that. What is the next cation?
Lithium ion.
Yes, Li plus and it is termed as lithium ion. What is the next ion?
Na plus sodium ion.
Very nice. Next ion?
K plus potassium ion.
Very nice. Next one?
Rb plus rubidium ion.
Very nice. Next one?
Cs plus cassidium ion.
Cesium.
Cesium.
Yes, it is called cesium. Great. Next one?
Be plus beryllium.
All right, all right. Next, now we have come to group 2. Cations from group 2, right? Be2 plus. Yes, what is the name? Be2 plus?
Beryllium ion.
Beryllium ion. All right. Next cation?
Mg2 plus magnesium ion.
Very nice. Which one is the next cation?
Ca2 plus calcium ion.
Very nice. Great. Next one?
Sr2 plus strontium ion.
Strontium. Strontium, strontium. You can pronounce it like that. All right. Okay. Next cation?
Ba plus barium ion.
Barium ion. Very nice. Very nice. Okay. Till this I think we have covered in our last class. All right. Okay. There are some more type of cations. All right. And one more thing. After this thing, what you need to do is you need to leave 2 more pages just after this, because there are some more type of cation. There are some groups. Are you acquainted with these names beforehand, or you could do it now?
No.
All right. Great, great, great work. Fluoride ion. This is chloride ion, and this one is bromide ion. This one is iodide ion. Iodide ion. Okay. All right. Okay. Now, can you write names of some more ion? Okay. We will relate these ions with their group. All right. If we relate it with their group number, we can easily understand, like group 17 elements are just 1 electron short with respect to their respective noble gases, right? Noble gases have complete octate in their valence shell, right? Can you relate it? Okay, like neon has 10 electrons, so what will be the electronic configuration? 2, 8, right? All right. If we check about argon, argon has electronic configuration 2, 8, 2, 8.
2, 8.
Yes, there are total 18 electrons. We have already
288.
Good. So we can easily check here valence shell as complete octate, right? Okay. So this is the main reason why they show this much stability, and they do not generally tend to form any compound. All right, because they are already stable in monoatomic form, right? All right. Okay. And halogens are just before this, right? This is group 18 element, and halogens were group 17 element, right? So 1 electron, if we add 1 electron to each of them, each of the halogens, they will attain the electronic configuration of their respective noble gases, and they will be stable. Okay. Now, if we want to check about, you have to be careful here. Okay. If we want to check about group 16 elements, all right. Okay, so group 16 elements, in order to reach the stable octet configuration of group 18 elements, they will require 2 extra electron, right? Particularly for group 2 and particularly for period 2 and period 3, they will require 2 extra electrons, all right, in order to attain octet configuration in their valence shell, right? Are you getting my point? Yeah, okay. So for oxygen element, how many electrons are there? 8. Okay, so can you tell me about its electronic configuration?
2 6.
Very nice. So if we add 2 more electrons, will it be like this? Got my point? Okay, this is the reason why oxygen have, when we take its anion form, it usually oxide state is usually O2 minus, all right. And like this, sulfur also, it gains 2 electron to form S2 minus ion, all right. This is the general sulfide, this is the general oxide form, all right. Okay, okay. Like this, if hydrogen attains 1 extra electron, if it gains 1 extra electron, it will reach the electronic configuration of helium, right? Because it has now 2 electrons. Got it? Okay. So can you name them? What will be the name of O2 minus ion? What will be the name of S2 minus ion? What will be the name of H minus ion? Can you relate it?
H minus ion.
Yes, from hydrogen, you have to just replace the last some words, last some alphabets, and use IDE, ion there, right? This is what you had done earlier in case of halogen, right?
Nothing.
Oxygen,
Hydrogen
oxide ion, right? We term it as oxide ion. IDE will be added, all right. For sulfur, we have to write sulfide ion, IDE, okay. Last some alphabets are removed and we call it as sulfide ion. In case of hydrogen, we write it as hydride ion. Got it? Okay. So the name here will be oxide ion. This is the general oxide form. Okay. There are some more oxides. We will learn about them. Okay. And this is the general sulfide ion. Sulfide ion. This is hydride ion. Hydride ion. Okay. Now can you relate it? Why H is gaining only 1 electron? It is not gaining 2 electron like these two. All right. Why? Why is it so? Can you answer it? You can try. Can you try? If it gets if hydrogen gains 2 extra electron, it will have 3 electrons, right? Okay. And what is the immediate noble gas which is nearest to hydrogen?
Helium.
Helium. How many electrons? What is the electronic configuration of helium?
2.
Only 2. So if hydrogen attains the stable electronic configuration of its nearest noble gas, that is helium, it will be stable. Why will it require extra electron? It will not need extra electron, right? It is already stable. Okay. So it will not take or not accept another electron from anywhere. All right. That is why it is stable in form of H minus. It will not form H2 minus. Got it? Okay. So the driving force is nearest element with respect to that particular element, which is the noble gas. It already has stable electronic configuration. The element just tries to attain that electronic configuration, which is the electronic configuration of its nearest noble gas. Got it? Okay. So this is not formed. This will be formed. Okay. Everything is all right? Have you written the points from here? Okay. Write it carefully. It is important. Okay. Write it carefully. These are the basics of cation, anion, and why if some element is forming any anion, why does it form like that? It is the basics. Okay. Have you written it? Okay. Noted? Okay. All right. Now, I am simply writing N3 minus. Its name is, the name of the element N is?
Nitride.
Good, very nice. Element N is known as nitrogen and N3 minus will be known as nitride ion. Very nice, very nice. Okay? And can you relate it? Why is it like this and not like this or not like this? Can you relate it? Why is it correct and why these two are incorrect?
Because it gains 3 electrons
Yes, to attain,
to attain octet.
yes, to attain stable electronic configuration of its nearest inert gas. All right? Okay. And nearest inert gas with respect to nitrogen is
Let- Any.
neon, correct, neon, right? Okay. So, nitrogen has 7, atomic number 7, right? It has 7 electrons and after gaining 3 electron, it will have now total of, some total of 10 electrons, all right? And neon has atomic number 10, it has 10 proton and 10 electron, all right? So, it is obvious now it has attained the electronic configuration of nearest noble gas, okay? I think now you can relate each and every IDE ion, right? These type of anion, I think now you can relate it. Okay? Got the concept? Everything is clear? Shall we move forward? Okay. Now, I am going to write some more ions here and you have to relate it, okay? Like C4 minus, what will be its name?
Chloride.
No, it is not Cl minus.
Just C.
C, carbon. Element's name is carbon.
Carbide.
Carbide, very nice, great, great, great effort. Carbide ion, okay, good, awesome. Okay, some more ion, P3 minus, what will be its name?
Phosphide.
Phosphide ion, okay. I think now you are able to relate it, the name and the ion and the charges. You don't have to remember it or mug it up like, okay, N3 minus, P3 minus, like that, right? You can relate it, why it is like that. Correct? Okay? Okay. Now we will write some more names of anion because they are very common, okay? Alright? And they are organic substance. Do you know what is organic substance?
Organic.
Can you relate it with day to day, some things are there in our news, right? Organic food, organic,
Things from nature.
yes, directly which are obtained from nature, all right? So, initially there were some substances which were directly obtained from living things, okay? And they were termed as organic substances, okay? But now we can convert organic and inorganic substances into each other, not all, but some of them can be converted. All right, okay. So there is no limitation like organic substances cannot be made in our experimental labs. It is not like that nowadays, okay. But initially it was thought like that. Organic substances are directly obtained from nature. It is directly obtained from trees, plants, something like that, okay. And main element, main thing on which organic substances are based are hydrocarbons, okay. Hydrocarbon or hydrocarbon derivatives are known as organic compound or organic substances, okay. We will know more about them in our coming classes, okay. It will be like it will take much more time, Okay, all right. Now let's try to recall this. What is this? Can you recall it?
CH3C.
Have you seen this
Deketo.
formula? No, no, no. It is acetic acid. What is this? It is
Acetic acid.
acetic acid. Okay, can you tell me one more thing? Where is formic acid used, or where is it found in nature? Formic acid.
Formic.
In the bee, ant sting or bee sting also these acids are found, right? We tell it now.
Formic.
Yes, it is formic acid. Red ant. Red ant is there. It generally,
H is TOOH.
formic acid's formula is HCOOH. It is like this. Okay.
हाँ ये discuss हुआ था
Okay, okay, okay. It was already discussed. Okay.
preservatives के
हाँ हाँ.
preservatives
Yeah, yeah. It is also used in preservatives. Okay. It is also used in our day-to-day life. We use pickles, right? In our home we use pickle, right? There also it is there. It is present there. Okay. These acids are present there. Okay. Now, if we take out H plus from here, okay, from these acid we can get some anion like CH3COO minus ion. It is called as acetate ion. What is the name of ion? What is the name of ion? Acetate ion. Okay, the name is derived from its acid. All right. Everything is fine in your laptop? Is it working fine?
थोड़ा issue है
All right, all right. Yes, you can rejoin. Screen is visible now. Everything is clear. All right. Okay. So what is the name of this ion? CH3COO minus. It will be called as
acetate
acetate ion. From where it is getting its name? From the acid.
acetate
Okay. Yes, from acetic acid. Okay. And these two acids, common acid, it was you can say it as it was identified in very early stages. Okay. These two acids were known to scientific world from very from earlier times. Okay. All right. So this name is carried out and we call CH3CO minus ion as acetate ion. Okay. And what will be the name of this ion? Can you try and name it? Acetate ion from acetic acid.
formic तो नहीं
Formate. Acetic, acetate, ATE. Formate.
formate
Formate ion. All right. Formate ion. All right. Okay, and these two, the name of ion you have to just highlight like this. Okay, so that whenever you revise it, you can easily check where are the ions, where are the anions written in your notebook. All right. Okay, there are some more anion. There are various classes of anions. All right, and in these anion classification we have to leave more pages with respect to cation. All right, we have to leave I think almost 3 to 4 pages. Okay, and we will write name of some more ion like O2 2 minus ion. This is known as peroxide ion. All right. Okay. How is it related? We will get to know about it in our subsequent classes. Okay. And O2 single minus. Okay. You have to write it carefully. See, oxygen has 3 type of ions. Okay. What is the name of this one?
O2.
Yes. What is its name?
From.
From.
Try.
You can take help of your notebook. Today also you have written the name of this ion.
Superoxide.
No. It is written already in your notebook. Flip your pages. You will find it. O2 minus. Oxygen element has simply gained 2 extra electron. This is single oxygen atom, right? Okay. So it will be termed as oxide ion, right? Check it. Where have you written oxide ion? Check it. Where have you written it? O2 minus. In today's class only you have written it. Look, I'll show you. Got it? Yes. Oxide ion, right? Okay. When the element is in its elemental state only, like that element is taken, and simply what we have done is that particular element has attained its nearest noble gas configuration by accepting some electron, then those elements or those ions will be termed by using IDE ion, right? All right. Same is the case here. This is the single oxygen atom and it has gained 2 extra electron to attain the electronic configuration of neon. Okay, so it will be termed as, from oxygen, it will be termed as oxide ion. All right. But these 2 cases are different because here it is not single particular element or single atom is not there. All right. Got it? Got the point? Got the difference? Okay. So if O2 minus is there, if atomic elemental oxygen is there and it has gained 2 extra electron, it will be termed as oxide ion. Okay. But these 2 cases are different. O2 2 minus is peroxide ion and O2 2 oxygen atoms are connected and single electron they have gained. Okay.
Superoxide.
Yes, that is superoxide. Correct. That is superoxide ion. Okay. All right. OH minus ion, this radical will also be used. Look, now different atom, group of atoms are there and they have gained a single electron. Okay, group of atom is there and they have gained a single electron. Okay, so these can be termed as negative radicals. Okay, and its name is hydroxide ion. What is its name?
Hydroxide.
Hydroxide ion. Okay. It is commonly used, like in case of NaOH, we term it as sodium hydroxide. All right. Got it? Similarly, there are some more ions. PO4 3 minus, phosphate ion. From acid, we can remove the H plus and we can get this ion, PO4 3 minus, phosphate ion. Okay. All right. And there are some more ion like SO4 2 minus.
Sulfide. Sulfuric.
H2SO4 is sulfuric acid. Look, sulfuric acid is like this. Its structure is like this. Okay. This is the, yes, this is the structure of sulfuric acid. Okay. What we have done is oxygen has taken this negative, the electron of hydrogen is gained by this oxygen and hydrogen has lost its electron. Okay. So it is like this now. Okay. So we can write it as S, single S is present and how many oxygen is present?
4.
4 oxygen is present, SO4, and how many charges are present?
-2.
-2, 2 minus. So this will be sulfate ion, phosphoric acid, phosphate ion, sulfuric acid, sulfate ion, sulfate ion. All right. And one more ion is there, it is carbonic acid, carbonate ion. CO3 2 minus is carbonate ion, carbonate ion. H2CO3, it is also known as carbonic acid. H2CO3 is also known as carbonic acid. So it is carbonate ion. All right. Okay. Now you have to leave 4 pages, 4 blank pages after this. Okay. And we have today learnt about some basic cation and anion in this class. And now what we need to do is, we need to use this cation and anion to make a compound. Okay. Salt is formed when cation and anion are placed together. Okay. Like NaCl, sodium chloride, right? Na has single charge, right? Na plus Cl minus. Okay. Sodium chloride ion, it will be termed as sodium chloride. Okay. And valency is same here. So valency is crisscrossed in this case, right? We don't need to write 1 1 here. All right. I think this has already been discussed in your previous classes, I think, right? Okay. Because one day you were talking about this thing only, right? So what is the thing which is getting crisscrossed? So it is simply this magnitude. We have to keep this point in mind. Simply this magnitude is crisscrossed here. If it is 1, we don't need to write it. Okay. We can simply write it like this. It already means like Na, one single Na, single Cl is present. Okay. Now if we want to write about some different compound, let's take this compound this time as some base, MgOH whole 2. Okay, magnesium hydroxide, magnesium and hydroxide ion, we are trying to mix it. Okay, so hydroxide ion, yes, what will be the formula?
MgOH.
Very nice. So this one, it will come here, and this too, it will come here. It will be crisscrossed. So it is not the atomic number which is getting crisscrossed, it is the valency or the charges present here. Okay. And it is done in order to get a neutral compound. Okay. Overall charges must be balanced, because a compound or a atom in its normal neutral, it is normally neutral in state. Okay. A compound is neutral in state. Alright. If it is forming a compound, it will be neutral, it will be stable. Then only it will form that compound. Is that clear? Okay. So what is it? What is it called? Which we have to crisscross? It is generally called the valency or the charges present at that particular cation or anion. All right. Okay. So the formula will be MgOH whole 2. All right. What will be the name of this MgOH whole 2? What will be the name of this compound?
Magnesium hydroxide.
Magnesium hydroxide. Very nice. Okay. In this way, we can write name of different compound now. We have lots of cations and lots of anions in our notebook now, right? And we can just juggle them up to form different compounds, all right? Okay, and these compounds must also be present in our atmosphere, all right? Aluminium sulfate, try it. Aluminium sulfate. Can you write its formula? You have to try it now. What will be the first step?
Al.
Yes.
Al2SO4 whole thrice.
Very nice. Okay, what will be the first step? At first, from aluminium, this is generally the part where cation is present, right? Aluminium, how is aluminium represented? It is represented by
Plus 3 charge.
Al plus 3 charge. Very nice. And how can we represent sulfate ion? SO4?
Minus 2.
Very nice. You can write it as 2 minus or minus 2. That is completely fine. Okay. And now what we need to do is we need to take these two numbers and we need to crisscross. Okay. So we will get the formula as, and if there is group of atoms somewhere, if it is in cation side or in anion side, we have to use this parenthesis part, we have to use this bracket part. Alright, this we have to keep it in mind. Got it? Okay, so you will get homework related to this thing today. Alright, and now let us discuss about the question 2 of your homework 4. Alright, so that you can do the sum which is given in next part of the question 2. Alright, okay, so let us discuss first part of question 2. Can you read the question for me? Have you written it in your notebook?
Let me see.
Is it written in your notebook?
No.
Okay, alright, okay. Okay, don't worry, I've got it. So here it is. Question 2 was, question 2, I am writing here for you. Count the number of single, double or triple bond, triple covalent bond was there. These were all types of covalent bond, right? Single, double and triple bond were all types of covalent bond, right? Present in the following compound, present in the compound. Okay, and okay, which part you want to be discussed in class? There were 4 parts to this question. Which part do you want to be discussed in the class? Third, all right, okay. You have the question or you have just selected it arbitrarily?
Huh?
You have the question right now or you have just selected it arbitrarily? Like you have just selected from the anyone from the 4, like that you have selected it? All right, okay, okay. So arbitrary selection of question, that's fine. C, double bond C, H, one H is present here, and C, double bond C, H, single H is present here. This is the question written in the part C of question 2. Now what you have to do is you have to identify, in order to count the number of total covalent bonds here, that 2 different type of bonds you have to count. Okay, so first what you need to identify is which bonds are present in this particular compound. Okay, so is triple bond present in this particular compound? Can you locate them? Okay, so triple bond is not there. Okay, can you locate double bonds present in this compound? All right, how many double bonds are there?
2.
All right, okay. So what you have to do is you have to just count the number of single, double or triple bond present in compound. Okay, I think now you got the question. Okay, can you do it now for me? Double covalent
Double
bond.
bond 2.
Yes, correct answer. What will be?
And
Triple bond
single
is not
bond, sir.
present. Okay, triple bond is 0. Triple covalent,
Single bond, sir.
single covalent bond. 1, 2, 3, 4, 5, 6 and 7. Right? Like this you have to solve this question. Okay, can you do it for me? Okay, this will be your homework for next day now. Alright, and one more homework you will get it, and what you have to do is you have to solve all of them. You have to write it in your notebook and then you have to solve them. Okay, and send it before next class. Okay, and tomorrow at this time will be our next class. Okay, everything is fine? Okay, so we are wrapping our class today. Thank you so much. Okay.